Section 3.3 Increasing and Decreasing Functions and First Derivative Test. In Section 3.3, we're going to look at the graph of a function and find out its relationship with its derivatives. So let's look at the first graph. I have pictures of increasing functions, and both of them are increasing. This is a definition of an increasing function. If x2 greater than x1 and f of x2 also greater than f of x1, then f is increasing. What does that mean? You can see from the first graph, this point right here is x1 comma f of x1, and this point right here is x2 comma f of x2. And you can see x2 is larger than x of 1, and f of x2 is also larger than f of x1, then function is increasing. In other words, as x gets larger, y gets larger too, then function is increasing. Same thing, graph is a little bit different shape, but you can still see as x gets larger, the y value gets larger as well too. So we can see function is increasing. From left to right, graph is going up. That will be increasing function. Similarly, as x gets larger, this time y gets smaller. So you can see in the first picture, x2 is greater than x of 1 since it is located on right hand side of the number line. However, f of x1 is larger than f of x2. So accordingly, as x gets larger, y values got smaller. So you can say that then function is decreasing. Second picture too, you can see how x2 is larger than x of 1. However, f of x1 is larger than f of x2. So therefore, this function will be decreasing. So as you look at the graph from left to right, if a graph is going down, it will be a decreasing function. Third, there will be also a constant function. You can see whether you have x of 1 or x of 2 or for any other x values, your y value is always the same. There's no changes in y's. In other words, your function y value is always constant. Then we say f is constant, or we also call the constant function. Back to the first graph. At x of 1, the slope of this function is positive. What about at x2? At x2 also. And in fact, at any point when function is increasing, slope of tangent line is always positive. And that's not a coincidence. You can see even from the different shape of graph, if a function is increasing, slope at any point is positive. So the characteristic for increasing function is that f prime of x is always positive for increasing function, for all x at the moment when it's increasing. What about for decreasing function? For the decreasing function, look at x1. The slope of this tangent line is negative this time. If it's decreasing, slope of a tangent line at that point is negative. So if a function is decreasing, then f prime of that x value will come out to be negative since the slope is negative. And as you can see, what would be slope of constant function? Since it's a constant, it is 0. So for constant function, f prime of x will be equal to 0. So that gives us test for increasing and decreasing function. Without even a graph given to us, if you got an equation of a function, then you can actually find out in what interval this function will be increasing or decreasing. So this is the test for increasing and decreasing functions. let f be continuous on closed interval a to b and differentiable on open interval a to b. If f prime of x is greater than 0 for all x in this interval, then f is increasing in that interval. And if f prime of x is less than 0 for all x in that interval, then f is decreasing on that interval. And if f prime of x equals 0 for all x in that interval, then you can conclude that f is constant on that interval. All right, let's see if we can apply that to a problem. Find the intervals on which f of x equal 3/4 x to the 4th minus 2/3 x to the 3rd minus 1/2 x squared plus 5 is increasing or decreasing. And in order to find out interval of increasing or decreasing, your first step is find its critical point. Because critical points are the points that f prime is 0 or f prime is undefined. So then any other point that f prime is not 0, it has to be either positive or negative. So we can draw a number line and locate the critical numbers, and then you can test each interval to see if f prime is positive or f prime is negative. Because if it's not 0, it has to be positive or it has to be negative. Okay, so let's first find its critical point. So f prime of x then is equal to 3x to the 3rd minus 2x squared minus x, and derivative of 5 is 0. Now, this f prime is defined on all real numbers. This is never undefined. So only way you are going to get a critical number from this f prime is if it was equal to 0. So let's factor it. I have a common factor x, so I'm going to pull that out. And then I get 3x squared minus 2x minus 1. Now, this guy factors more as x times 3x plus 1 times x minus 1. And this is never undefined. So then only way you're going to get a critical number is if this f prime of x was 0. And when is it going to be 0? If x was equal to 0 or negative 1/3 or positive 1. So you have 3 critical numbers, and they are x equals 0, x equal negative 1, x equal 1. So now draw a number line and locate the critical numbers from smallest to largest. So I got negative 1/3, 0, and 1. So now you can pick test points for each interval separated by critical numbers to test the signs of f prime to determine the intervals on which f is increasing or decreasing. Pick test points. And what should be test point for any number less than negative 1/3? I'm gonna choose negative 1 for test point. And then what would it be any number between negative 1/3 and 0? Well, negative 1/3 is negative 0.3333. So you can choose negative 0.1. And then I could choose 0.5 for any number between 0 and 1. And let me choose 2 for test point for any number greater than 1. After you pick these test points, you are going to plug it into your f prime, which is this is easier since these are product of 3x values in it. So then you can just find out by sign whether that's going to give you positive or negative. In other words, if you were to choose negative 1 for test point, you literally have to plug negative 1 to here for x, and this x, and this x, and multiply 3 values to see what sign it gives you. So if you plug negative 1 for x, you get negative. If you plug negative 1 for second quantity, it's a 3 times negative 1, which is negative 3 plus 1 is still negative. And negative 1 minus 1 on the third parenthesis, it will give you still negative. And because you multiply three negatives, sign of this interval is going to be negative. Now, we're going to test negative 0.1. So if you plug negative 0.1 to, again, where? You're going to plug it in here, and here, and here. Every x you see in your f prime, you're going to plug negative 0.1. Negative 0.1 is negative. 3 times negative 0.1 is negative 0.3 plus 1 is positive 0.7, so it is positive. And negative 0.1 minus 1 is negative. So since in the product you only got two negatives, this product is going to be positive. So this interval is positive. Now let's plug 0.5 in there. When I plug 0.5 to, again, here, 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 then I'm gonna get 0.5 is positive. 3 times 0.5 plus 1 is positive. 0.5 subtract 1 is negative. And since there's only one negative in the product, it's going to be negative. So this is negative. Let's test 2. 2 is positive. 3 times 2 plus 1 is positive. 2 subtract 1 is positive. And product of three positive numbers is positive. So this is a positive. Recall, if f prime is positive, then f is increasing on that interval. If f prime is negative, then f is decreasing on that interval. So you can now conclude that f is decreasing on this interval, increasing on this interval, and decreasing on this interval, increasing on this interval. So you can conclude that f is increasing on the interval. Which one is it? Increasing interval is right here, and you always give open interval. And because it's a two interval, you're gonna use a union symbol in between the two interval. So f is increasing on open interval negative 1/3 to 0, union open interval 1 to infinity, and f is decreasing on negative infinity to negative 1/3 and 0 to 1. And since that's also two interval, you're gonna say f is decreasing on open interval negative infinity to negative 1/3, union 0 to 1, open interval. Forced derivative test. Forced derivative test is test to find the relative extrema. Let f be continuous on an open interval containing a critical number c, and let f be differentiable on the interval, except possibly at the point c. Recall, a critical number means f prime of c equals 0, or f prime of c does not exist as far as f of c exists. So there are two kinds of critical number. So we have two graphs where one of them f prime of c does not exist, and another where f prime is equal to 0. Now, either way, if f prime sign changes from negative to positive at critical number c, then c comma f of c is a relative minimum. Do you get that? Because if f prime is negative, then your original f will be decreasing at time. And if f prime is positive after the critical number c, then your original f will be increasing. Then you are gonna have a valley there. And that critical number will then give you relative minimum. And relative minimum is original function value. So your point c comma f of c is the relative minimum it's saying. Make sense? Same thing, even if let's say f prime c equals 0, so that slope of tangent line at x equals c equals 0, still, if f prime sign changes from negative to positive, then graph before c is decreasing, and then after the c it will be increasing, which will still create a valley there. So graph will have relative minimum there. Similarly, let's say your f prime sign changes from positive to negative, then your original graph will be increasing and then decreasing after the point C. Therefore, at C, you're gonna have a hill there. So you're gonna have a relative maximum at C with relative maximum value f of C. Same thing if f prime of C equals 0 and f prime sign is positive before the point C and f prime sign switch it to negative. After the C, then because your original f function will be increasing in that interval of f prime is positive and it will be decreasing after the point C where f prime is negative. So you are gonna have hill there, which will produce relative maximum point at x equals C, maximum value f of C. So this is the first derivative test. I never really had to memorize when I was a student because this was very natural. I could follow my hand. F prime negative, so my hands go down and then my hands needs to go back up as the function increase. I can see when I follow my hand going down and then up, I see I have a valley there. So there is relative minimum there at that critical number. And if f prime changes from positive, which means graph is increasing, and then it goes back to negative, which means my original graph goes down. So then by following my hand going up and then down, I can see naturally I'm going to have a hill there. So that will give me relative maximum at the critical number. So in next problem, we're gonna actually find the relative extrema using first derivative test. Find the relative extrema of function f of x equal radical 3 over 2x plus sine x on the interval 0 to 2 pi. So what is the first step, guys? My first step is find the f prime of x and find the critical numbers. So f prime of x is equal to derivative of radical 3 over 2x is radical 3 over 2 and derivative of sine x is cosine x. And I'm looking at the interval 0 to 2 pi. I'm looking for critical number in the interval 0 to 2 pi. And this radical 3 over 2 is a constant and cosine x is defined on all real numbers, meaning f prime of x is defined on all real numbers. So that only way you're gonna get a critical number, since f prime does not exist, never happens, only way you're gonna get a critical number is if radical 3 over 2 plus cosine x was equal to 0, which means cosine x was equal to negative radical 3 over 2. And I'm only looking at from 0 to 2 pi. All students take calculus. So cosine is negative on the second quadrant and the third quadrant. And reference angle for the second quadrant is pi minus the theta. And cosine is radical 3 over 2 when it was pi over 6. So do the pi minus pi over 6, x equal to 5 pi over 6. And then reference angle for the third quadrant is pi plus theta, which is pi plus pi over 6. So that will give me 7 pi over 6. So this is my critical numbers in the interval 0 to 2 pi. Step 2. Now we're going to draw a number line and locate the critical numbers that we found in step 1. But note that we are only looking at the interval 0 to 2 pi. So I'm actually going to only draw from 0 to 2 pi, and I left it open since it's an open interval. And our two critical numbers were 5 pi over 6 and 7 pi over 6. So we are about to test the signs of f prime for each interval divided by critical numbers. So now we're going to pick a test point for each interval. What would be a good candidate in the interval 0 to 5 pi over 6. Note that this is going to be your f prime. So make sure that you pick a number that is easy to calculate, although you can use calculator. And when you use calculator, make sure you are in radian mode. So I'm going to use pi over 2 since the cosine of pi over 2 is easy to calculate. And my second test point in the interval 5 pi over 6 to 7 pi over 6 is pi. And my third test point in the interval 7 pi over 6 to 2 pi will be 3 pi over 2. So f prime of pi over 2, it's going to be radical 3 over 2 plus cosine of pi over 2. And cosine of pi over 2 is 0, so this is positive. Now, when you plug pi, f prime of pi is radical 3 over 2 plus cosine pi. And cosine of pi is negative 1. When you add with radical 3 over 2, it is negative. I don't have to know what it is. I just have to know the sign here. So now, lastly, my f prime of 3 pi over 2 is radical 3 over 2 plus cosine 3 pi over 2 is 0. So I get positive number again. And since my f prime sign changes from positive to negative at critical number 5 pi over 6, I'm gonna have relative max here. And also, because my f prime was negative in the interval 5 pi over 6 to 7 pi over 6, and it is positive now, so that my f will be increasing there. So then I'm going to have a relative minimum at 7 pi over 6. And since it says find the relative extrema, let's go ahead and find it. Remember, relative extrema are function values. So you literally need to plug these critical numbers inside of original function f to find out what the relative max is and relative min is. So let me create a room here. So my relative max is 5 pi over 6, comma, f of 5 pi over 6. And f of 5 pi over 6, remember, this is my original f of x. That's where you need to plug it in. That will be radical 3 over 2 times x. My x is 5 pi over 6 plus sine of 5 pi over 6, which is equal to 5 pi radical 3 over 12 plus sine of 5 pi over 6 is 1/2. So have a common denominator, 12, by multiplying top and bottom of 1/2 by 6. So your relative maximum is 5 pi radical 3 plus 6 over 12. So my relative maximum is 5 pi radical 3 plus 6 all over 12. And my relative min happens at 7 pi over 6. And f of 7 pi over 6 is radical 3 over 2 times 7 pi over 6 plus sine of 7 pi over 6, which is 7 pi radical 3 over 12 minus a half. So by multiplying top and bottom of minus a half by 6, we have 7 pi radical 3 minus 6 all over 12. So my relative minimum is 7 pi over 6, comma, 7 pi radical 3 minus 6 all over 12. So I found relative maximum and relative minimum. Okay, find the roots, relative extrema, and sketch the graph of f of x equal x to the 4th minus 4x squared. So we're going to locate the zeros of this function. Zeros are the roots. And then we're gonna also find the relative extrema. We're gonna know when function is increasing and when function is decreasing. So therefore, we're gonna have a very good sketch of f of x. So let's do that. So to find the roots, we set original function equal to 0, right? So f of x, which is equal to x to the 4th minus 4x squared, set it equal to 0. I can factor out x squared minus 4 equals 0. This factors more. X squared, x plus 2, x minus 2 equals 0. So I have a 3 roots, which is 0 and plus minus 2 are my roots. Now let's find the f prime of x to find the critical number and find the interval of increasing and interval of decreasing, and also find the relative extrema. So it will be easier for us to graph. So f prime of x is equal to 4x to the 3rd minus 8x. I am, of course, taking derivative of this right now. So then this is always defined, so does not exist, never happens. And this will be 0 when factor out 4x, and I have x squared minus 2 equals 0. And for x, I can still factor in irrational. This is x plus radical 2, x minus radical 2 equals 0. Or you could solve it for x squared minus 2 equals 0. So x squared equals 2. So x is equal plus minus radical 2. That's okay too. So anyway, my 3 critical numbers are x equals 0 or x equal negative radical 2, positive radical 2, and these are my 3 critical numbers. So you can locate critical numbers. Here's 0. Radical 2 is about 1.414, so it's about here. I'm gonna locate right below the graph where the number is, so it's easier for me to follow later. And then this is about negative radical 2 is, which is about negative 1.414. This is a positive radical 2. So let's find the f prime sign. Let me pick a test point. What is the good test point that is smaller than negative 1.414? I'll choose negative 2. And then any number between negative 1.414 and 0, that will be negative 1. This interval, I'm going to choose positive 1. This interval, I'm going to choose positive 2. And remember, I'm testing f prime sign. So you have to plug these test values on your f prime, and it's best if you use the factored form. That way you can just multiply signs. So if you plug minus 2 for this factor, I'm gonna get a negative. And then if you put negative 2 here, that will be negative 2 plus positive 1.414, so you get negative. And then if you plug negative 2 here, negative 2 subtract another radical 2 will give me negative number. So when I multiply 3 negatives, I'm gonna get negative, which means original f will be decreasing on this interval. Let's now test negative 1. Plug negative 1 for these all 3 x's. So then for x, negative 1, that's a negative. Negative 1 plus radical 2 is positive. Negative 1 minus radical 2 is negative. So then this product is positive, which means between interval negative radical 2 to 0, your graph will be increasing here. And then let's plug test number 1 to the f prime. When you plug positive 1, 4 times positive 1 is positive. 1 plus radical 2 is positive. 1 minus radical 2 is negative. So then you get negative, which means your original graph of f will be decreasing here. Last number, for interval radical 2 to infinity, plug test number 2. So now 4 times 2 is positive. 2 plus radical 2 is positive. 2 minus radical 2 is still positive. So this is positive, which means the original graph will be increasing here. So you can see what's gonna happen between this critical number, right? f graph will be what now? It's going to be decreasing and increasing and decreasing and increasing. So you're gonna have a 2 relative minimum and you have 1 relative maximum at 0. So let's find the relative max. Relative max is happening at 0. And what is f of 0? That is 0 to the 4th. You gotta plug it into original function. Minus 4 times 0 square, which is 0. So your relative maximum is 0. And then what's relative minimum? My relative min happens at, it was happening right here, which is negative radical 2 comma, and another one happens at positive radical 2 comma. And if you notice, this original function is even function. Whether you plug negative x and positive x, you're gonna get the same y value. So actually you can just plug one of them in there and they're gonna have the same function value for both negative radical 2 and a positive radical 2, because you're gonna make a power 4 and power 2, which makes it everything positive. So they will have a same y value. So f of, let's say both the plus minus radical 2 is plus minus radical 2 to the 4th power minus plus minus 4 times plus minus radical 2 square, which is equal to 4 minus 4 times 2 is 8. So I'm gonna get negative 4. So for both, I'm gonna get negative 4 there. So I'm gonna gather all information and now I'm going to graph it. First of all, what's my roots? Roots are the also called x-intercepts. So these are the numbers that are located on your x-axis. So my graph will pass through 0 and negative 2 and a positive 2. And then I will have relative maximum is 0, 0. This is my relative max. I should have a hill here. And then I have a relative minimum at negative radical 2. I said it was about negative 1.414. And then my minimum value was negative 1, negative 2, negative 3, negative 4. So I'm gonna have a relative mean here. I will have another relative mean at x equal radical 2 comma negative 4. And then you can see graph will be decreasing from negative infinity to negative radical 2. So my graph will be decreasing. And then you can see my graph is now increasing from negative radical to 0. And I'm going to have a relative max at 0. And then it goes back down from 0 to radical 2. And then hit the relative minimum again at radical 2 comma 0. So my graph will go back up and have a relative maximum here and go down here to have a relative minimum. And then again, your graph is going to be start increasing from radical 2 to infinity. So now after that, it's only gonna keep on going up. So you sketch the graph of f. Find the root relative extrema and sketch the graph of h of x equal x times radical 16 minus x squared. So to find the roots, we're gonna set h of x equals 0. So h of x, which is equal to x times square root of 16 minus x squared equals 0 if x is 0, or square root of 16 minus x squared is 0 if 16 minus x squared equals 0. That means 16 is equal to x squared, which means x is gonna be equal to plus minus radical 16, which is plus minus 4. So I found my 3 roots, and my roots are 0 and plus minus 4. Now let's find the relative extrema. And to find the relative extrema, I need to find the h prime of x. So h prime of x is equal to Well, this is a product of two functions, right? It's x times, let's rewrite it. This is x times 16 minus x squared to the 1/2 power. So you can call this f times g. So we're gonna do f prime times g plus f times g prime to take the derivative. And derivative of x is 1 times g is 16 minus x squared to the 1/2 power plus f is an x. G prime is a function raised to the 1/2 power. So I need to use chain rule, correct. So now our function is something to the 1/2 power. So you take the derivative of that, that will be 1/2 times something to the lose 1 power is negative 1/2 power. And I do not touch inside yet. And when you're done with derivative of outer function, now you take the derivative of inner function. And derivative of 16 minus x squared is negative 2x. So then I can see this 2 and this 2 can be canceled, but don't forget the negative. And I do have 16 minus x squared to the 1/2 power, 16 minus x squared to the negative 1/2 power. So they are common factor. So to factor this, you are going to factor out the lower power of the 2. 16 minus x squared to the negative 1/2 factor out. Now open bracket. That would give me 16 minus x squared to the what power? Negative 1/2 power plus what power give me positive 1/2 power? That will be positive 1. And fourth power, we don't have to write it, so you can leave it at that. This negative power of 16 minus x squared is all out. And what's left is this x and this negative x. So you multiply those two, I get negative x squared. So that when you clean this up, I get 16 minus 2x squared on the numerator. And this guy will go to the denominator and become positive power. But since 1/2 power is square root, I'm going to put it back inside of radical. And I found my derivative. To find the critical number now, I set it equal to 0 or when this derivative does not exist. When does this derivative does not exist? This derivative does not exist if denominator is 0. And denominator is 0 if x was equal to plus minus 4. Because then I will have a radical of 16 minus 16, which is radical of 0, which is 0, and denominator cannot be 0. It will make my h prime undefined. But it was defined at this point, and in fact, it was my root before. Is that right? So they are critical number. And when is numerator of this h prime will be 0? This will be 0 if x squared was equal to 8, so that 8 times 2 becomes 16. So that's when x squared equal 8, which means x is equal plus minus radical 8, which means x was equal to plus minus 2 radical 2. So I will have another 2 critical number, which is plus minus 2 radical 2. Now, we do have a domain issue, right? Because the square root function have a restriction in their domain. That is, I cannot have any negative input. So let's find the domain of h to sketch the graph of h. So to find the domain of h, you're going to have to set input of your radical function greater than or equal to 0. And this will be 4 minus x, 4 plus x has to be greater than or equal to 0. And you could draw the number line and find out on what interval of x this is positive, but to save time, you can sketch this really quick. Since the leading coefficient is negative, it's a parabola upside down, and your x-intercept is, as you see, negative 4 and a positive 4. And you can see your function is a positive, which is above x-axis when x is between -4 and 4. So that's gonna be the domain of that. That's a quicker way to find the domain instead of draw the number line and plugging 3 numbers in the interval less than -4 and the number between -4 and 4 and a number greater than 4. So anyways, domain of this function is -4 to 4, meaning this graph only exists from -4 to 4. So beginning of graph is -4 and end point of this graph will be +4. And I did have 4 critical numbers, and my 2 of the critical numbers are the end points, -4 and 4. And then the other 2 were 2 radical 2, and 2 radical 2 is 2 times the 1.414, so it's gonna be 2.8 something or -2.8 something. So it's about here and it's about here. So let's say this is a +2 radical 2 and this is -2 radical 2. So now you can pick test point, and I'm gonna pick this test point to be -3 and a 0 here and a +3 there. And the most simplified my h prime I can use will be this one is my h prime that is most simplified. And I can plug these numbers, test points, and look at the signs of quotient again. So if you plug -3 here for every x I see, -3 squared is 9. 9 times 2 is 18. And when you subtract 18 from 16, I get negative on the numerator. And then over 16 minus -3 squared, which is a +9, is square root of positive number, which is a positive. So negative over positive is negative. So my graph will be decreasing from -4 to -2 radical 2. Now plug 0. 16 minus 2 times 0 squared is 16, which is a positive, over square root of 16 minus 0 squared is also positive. And positive over positive is positive, so my function will be increasing on this interval. Test number 3. 16 minus 18, which is negative, over 16 minus 9, which is positive, square root of that, which is positive. So my quotient will be negative, which means my graph is decreasing here. I'm just gonna draw this time a line here just to see what my graph should look like. So my graph should be decreasing and then increasing and then decreasing, which will give me relative minimum here and relative max there. What's my relative maximum? My relative maximum happening right here, which is 2 radical 2 comma, and where do you plug this value in? Into your original function. So that will be h is of 2 radical 2. So h of 2 radical 2 is equal to 2 radical 2 times square root of 16 minus 2 radical 2 square, which is equal to then 2 radical 2 square root of 16 minus, when I square the 2, I get 4. When I square the radical 2, I get 2. 4 times 2 is 8. So I get 2 radical 2 times radical 8, which is equal to 2 times radical 16, which is 2 times 4. So I get 8. So here is my relative maximum. It is 2 radical 2 comma 8. And then what will be my relative minimum? My relative minimum occurs right here on my critical number when it is -2 radical 2 comma h of -2 radical 2 is equal to -2 radical 2 square root of 16 minus -2 radical 2 square, which is equal to -2 radical 2 square root of 16 minus 8, which is -2 radical 2 times radical 8, which is 2 times radical 16, which is 4. So I get negative 8. So my relative minimum is negative 8. All right, I found everything I need to graph this, and let's graph it. What are my roots? My roots are 0, negative 4, and a positive 4, and negative 4 is the starting point, and a positive 4 is the end point of my graph. I have a relative minimum at negative 2 radical 2, comma, negative 8, and I have a relative maximum at 2 radical 2, comma, 8. And my graph is decreasing from negative 4 to negative 2 radical 2. And then it increase up to that point. And then it decrease again after this critical number, after this relative maximum. So here is my graph. Okay, this is everything. In 3.4, you are gonna learn the second derivative test. Okay guys, this is everything in 3.3. Study hard again, and I will see you in section 3.4.